Good day to everyone. So in the last video, we have discussed about the finding the numerical solutions of the Laplace equations using the finite difference method, and we have discussed some of the examples, example sums to solve the to solve using the finite difference method. So in this video, we are going to use the same finite difference method to solve the Poisson's equation. So we already know that Poisson's equation is nothing but the uxx plus uxyy which is equal to some function of g of x. So in order to solve this Poisson's equation, we can use the finite difference method as usual in the we have used in the previous video for the Laplace equation. So we already derived the second order derivative for the x and y for the central difference approximation is uxx is equal to 1 divided by h squared u of I plus 1 comma j minus 2 of I comma j plus 2 of I minus 1 comma j. This is for the uxx. Similarly for uyy, I can write that in the terms of the y-axis, the time step is actually varying with respect to the k, so that I can write 1 by k square which is equal 1 divided by k square into u of I comma j plus 1 minus 2 of ui comma j plus u of I comma j minus 1. So we can directly substitute these two equations into the Poisson equation, so that I can find the 5-point approximation formula. So just substituting this equation, you will get this expression. So in order to simplify this equation, what I'm going to do is I'm going to multiply this equation by h squared, so that this h squared will get cancelled, and you will get here you will get h squared divided by k squared. Multiply in the right hand side, you'll get the h squared into this function of g of I comma j. That is what I have given here, so that I can just replace the h squared by k squared in the new variable called p. So the p squared, and which this is the formula. So and if I take the square kind of mesh, then h is equal to k, so that the p will be equal to 1, and then I can just substitute these values here. I get u of I plus 1 comma j plus u of I minus 1 comma j plus u of I comma j plus 1 and j minus 1 minus 4 times of u of I comma j, which is equal to h square times of g of ij. So in the Laplace equation, in the right hand side which is equal to 0, so that we can arrange the boundary values in the right hand side. However, in the Poisson's equation, we already have the right hand side is having the some h squared into gij. So this is the standard 5-point formula to solve the Poisson's equation. Okay. So now we will look into the one of the problem, the boundary value problem, to solve using the finite difference method. So I have given the boundary value problem uxx plus uyy, which is equal to x squared minus 1, and the boundary values are given as the modulus of x is already less than or equal to 1. Similarly, the mod of y is also less than or equal to 1, and the boundary values are all the u values are 0 of the boundary of the square. So using the 5-point formula with the square mesh of the time step of h is equal to 1 by 2, that means which is also equal to k. H is equal to k equal to 1 by 2. So using this time step, you have to solve the given Poisson equation. So say from this the problem itself, we know that the modulus of x is actually x and y is actually less than 1. That means both x having the positive and negative values having the less than 1 value, and similarly the boundaries of all the values are 0, so that I can write this I can draw the mesh point as in given here. So we can see that this is actually having the symmetric points with respect to the x and y axis. Suppose if I take this as the origin value u1 and this is x and y axis, you can see that this is actually exactly based on this x and y axis. You can get the symmetry in the point u1. Suppose if you have the u2 here, you get the opposite also, you have the u2. Similarly, if you use this point is u3, opposite side also u3. Similarly, this is u4 and this is u4. And similarly, if this is u4, this is also be the u4, and this is also the u4. And the u equal to 0, that means all the boundaries are 0. So the values given is already given, the boundaries already given. So we have to find out the values of u1, u2, u3 and u4. So you have to find out all these 4 values. And in order to find the solutions, we have to use the 5-point formula. So as we already know this, the 5-point formula is for the Poisson's equation is u of I plus 1 comma j plus u of I minus 1 comma j plus u of I comma j plus 1 plus u of I comma j minus 1 minus 4 times of u I comma j, which is equal to h squared times of g and I comma j. So since in this equation itself the boundary, that means that the right hand side is given as x squared minus 1, that means the function of gij is given as x squared minus 1, so that I can just replace this gij in terms of given in the given function. So I can write this gij as x squared minus 1, so xi squared minus 1. So the h value is also given, that is 1 by 2. So 1 by 2 divided the whole square given by 0.25. Okay, so this is the equation, the 5.5 formula, the standard 5-point formula. So using this formula, you can find the different equation, the set of algebraic equations. So if you substitute the values of I and j values here, then you can solve this equation in terms of the system of algebraic equations. Therefore, at 1, that means at the point of 0, 0, that means the time steps of h and k is 0, 0, so that I can substitute the values of y equal to 1 into this equation. I get u2 plus u3 plus u2 plus u3 minus 4 times of u1, which is equal to minus 0.25. So I can simplify this equation further as minus 2 times of u1 plus u2 plus u3, which is equal to minus 0.125. Because if you find that if this u2, you get the 2u2, 2u3 minus 4 times of u1, which is equal to this value. So I can divide this whole equation by 2, you will get this equation. So this is actually at the first point, or where the 0, 0. Suppose if you are moving one step right side, that means in the x-axis, then you will get actually incrementing the values of x in terms of 0.5, but still the y value is 0. So that at 2, you get the 0.5, 0. So at this point, that means at the u2 point, this point, you have to find the, if you are using the 5-point formula, you have the values of this one, this one, this one, and this one, so that I can get the right hand side is equal to 0. So this value is 0 plus u4 plus u4 plus u1 plus u4 minus 4 times of u2, which is equal to this value 0.25. Since x of I value is 0.5 here, so I can take the squared value here, so that 0.25 times of 0.25 minus 1, or I further simplify this equation as u1 minus u4 times of u2 plus 2 times of u4, which is equal to, suppose if you do the simple mathematical calculation, you will get the value of minus 0.1875. Okay. Now I can go since we have already calculated the values for this here and here. Now we have to move either upwards or downwards, so that at 3 we have the value of x is equal to 0 and y value is incremented by 0.5, so that at this point at this point, so this point u3, you have the values of u4, 0, u1 and u4 here, so that I can directly substitute into the 5-point formula, so that I get u4 plus 0 plus u4 plus u1 minus 4 times of u3, which is equal to 0.25 times of 0 minus 1, because the x value is 0 here, so that you can get 0 equal to 0 minus 1, and further I can simplify this equation as u1 minus 4 times of u3 plus 2 times of u4, which is equal to minus 0.25. Similarly, if you move into the next point, that means at this point both the x and y values are actually incremented by 0.5, so that at 4 you get the 0.5 comma 0.5. Both the x and y will be incremented, so that at this point you can find the values where this point 0, 0, u4 and u2. I can substitute the values here. So I get 0 plus 0 plus u3 plus u2 minus 4 times of u4, which is equal to 0.25 times of 0.25 minus 1, so that I can rectify further. Simplify this equation as u2 plus u3 minus 4 times of u4, which is equal to minus 0.1875 again. Now we have the fourth set of algebraic equations, 1, 2, 3 and 4. So using this set of algebraic equation, 4 set of algebraic equations, you can use the Gauss elimination method to solve the equation. Or you can just write this equation into the matrix form, so that you can solve this using the Gaussian elimination method. So the first you can writing in the 4 by 4 matrix. So first for the first equation, I'm going to collect the coefficients of u1, u2, u3 and u4 with the right hand side values. So I can which can be written as minus 2, 1, 1, 0. The second row is 1, minus 4, 0, 2. Similarly 1, 0, minus 4, and this one is 2, and 0, 1, 1 and minus 4. So this is the coefficients of u1, u2, u3 and u4, and in the right hand side I have the minus 0.125 minus 0.1875 and similarly minus 0.25 minus 0.1875. Okay, so this is the equation. As I already told you that, so if you want to simplify this equation, then you have to make the first row and first point of first line as 1. So that if we want to do that, you can do the transformation r1 divided by minus 2. If you do this, r1 minus r1 divided by minus 2, you will get 1 minus 0.5, 0.50, and this 1 minus 4, 0, 2, 1, 0, minus 4, 2, and this is 0, 1, 1, minus 4. And if you multiply this value by 2, you will get minus 0.0625 minus 0.1875, and here this is 0.25, similarly minus 0.1875. Okay, now if we want to make the first elements of the second and third row columns as 0, so that I can do the transformation as r2 is equal to r2 minus r1. Similarly r3 is equal to r3 minus r1. Suppose if I do this transformation, then I will get this form, the matrix as 1 minus 0.5, 0.5, 0, and this here you can 0 minus 3.5, and here you will get the 0.5, and this is 2, and here you will 0, 0.5 minus 3.5, 2, similarly 0, 1, 1 minus 4, and the right hand side will be equal to 0.0625, and this will be minus 0.25, here means 0.3125 minus 0.1875. Okay, so what I'm going to do is I'm going to again make the second row second column as the value as 0 or 1, so that I can do the other, I can make it as 1, so that I can make the transformation r2 divided by minus 3.5, so that I can write this the equation as in the formula as 1 minus 0.5, 0.50, and this 1, 0, 1, 0.14286, and this is minus 0.57143, 0, 0.5 minus 3.5, and this is 2, and finally 0, 1, 1 minus 4. The right hand side 0.0625, 0.07143, and here minus 0.3125, here minus 0.1875. And similarly, I want to make this second elements of this R3 and R4, row 3 and row 4 should be 0, so that I can take this R3, which is equal to R3 minus 0.5 times of R2. Similarly, R4 is equal to R4 minus R2. If I do this two transformations simultaneously to this matrix, I get 1 minus 0.5, 0.5, 0, this is 0, 1, 0.14286, minus 0.57143, and here 0, and this will be 0, and minus 3.42857, 2.28572, and similarly the final 0, 0, and this is 1.14286, and here minus 3.42857, and right hand side will get 0.0625. This one is 0.07143, and here 0.34822, and minus 0.25893. Okay. So next I want to make this row, the third column of this row 3 should be equal to 1, so that I can divide this row 3 by this value, so that I will get the value 1. Therefore, R3 divided by minus 3.42857. If I do this transformation, then 1 minus 0.5, 0.50, 0, 1, minus 0.14286, and minus 0.57143, and the row will be 0, 0, 1, minus 0.66667, and similarly here 0, 0, 1.14286, here minus 3.42857, and in the right hand side you get 0.0625, and this second value is 0.01743, sorry, 0.07143, and third value is 0.10156, and fourth one is minus 0.25893. And similarly, the third element of the row 4 should be equal to 1. I want to make it as 1, so that I can take the another transformation. R4 is equal to R4 minus 1.14286 times of R3. Suppose if I do this transformation to here, I will get the value as 1 here. So the final result is 1 minus 0.5, 0.50, 0, 1, minus 0.14286, 0.57143, and here you will get 0, 0, 1, minus 0.66667. Finally, the R4 value is 0, 0, and this is also 0, get minus 2.66667 again, and the right hand side will get 0.0625, 0.07143, 0.10156, and 0 minus 0.37500. Now we almost reduced the equation, so that the last equation, the last value, means that this value, the last equation will give from U4, which is equal to, this minus and minus will be cancelled, so that 0.375 divided by 0.26667, which is equal to 0.14062. Okay, so this is the value of U4. So if you substitute this U4 into the third equation, we get U3, which is equal to 0.1010156 plus 0.66667 times of 0.14062, which is equal to 0.19531. So this is the value of U3. So now you get the values of U3 and U4. So you can substitute into the third equation. You will get U2, which is equal to 0.07143 plus 0.14286 times of 0.19531, which is equal to, plus the remaining values 0.57143 into 0.140062, which can be given as 0.17969. So that is the value of U2. Okay. So now we can easily solve this. Substitute all these values into the first equation. We'll get U1 value, which is equal to 0.5 times of 0.17969 plus 0.19531 plus 0.0625, which is equal to 0.25. So this is the value of U1. So now we have calculated the values of U1, U2, U3 and U4, which can be directly substituted into this mesh points, so that we can find these values into this area. Okay. Similarly, you can solve any Poisson equation problem using this 5-point formula. So only thing is you have to remember this equation, and the formula 5-point formula. Then you have to accurately apply this Gauss elimination method to solve the final values. Okay. So I stop here. So in the next video I will explain how to use the finite difference method to solve the heat equation using the explicit as well as the implicit method, which I can discuss it in the online class. And if you have any doubts in this video, we can also discuss it in the online class. Okay. Thank you.